Hi everyone, this video we're going to be going over factoring. It's more advanced factoring than the simple factoring we went over in the last video. These are the guided notes. It says factoring all factorable quadratics at the top. It should be right underneath the resources tab in the module. So if you don't have the guided notes for this video, pause right now, get the guided notes. So last video we talked about factoring, but it was simple factoring. It was when the leading coefficient was 1. So like x squared plus 4x plus 4 type thing, where the leading coefficient's a 1, or a prime number, so if we put a 2 out there. Okay, today we're going to up the difficulty a little bit. Sorry, I left my eraser over here. But at the same time, we're actually going to make it easier. So last video we had a couple of methods. We had a guess and check method and a more simple guess and check method with the leading coefficient 1. Problem is, it's guess and check. There's not just one way, and we know it's going to come out. You have to guess and check a bunch of different numbers. So today we're going to go over a method that there is no guess and check. It's called the AC method. You're going to see why in a second. I will say, and like it says here, bolded and underlined, if you only remember one method of factoring, like if there's just only one method that you can remember ever, it needs to be the AC method. Okay, the AC method always works, where the other methods, it depends. There's certain circumstances where they're easier, but the AC method always works. So if there's only going to be one way of factoring that you remember, make sure it's this method I'm about to show you. And just a reminder, factoring is probably one of the most important things you'll learn in high school math to prepare you for other math classes later on. So this is a big deal. AC method. Now I have the steps written out here. I'm not going to write them on the board just so I can save some room. But we use the generic form of a quadratic. So ax squared plus bx plus c. All right, the reason we call it AC method is because the first step is we do a times c. So we take the leading coefficient and multiply it by the constant. Okay, remember the constant is the term without any letters, without any variables. And the leading coefficient is the number being multiplied to the letter with the biggest exponent, or the variable with the biggest exponent. And that's why it's called the AC method. You have the steps here. Some teachers like this acronym, Margot. I don't like it because I feel like it leaves some stuff out that isn't intuitive, that they think is intuitive, but it's all right. If this helps you use it, I don't care. All I care about is that you understand how to factor and that you can factor. So let's go through this example here on the second page. It's one of those easier ones or one of the simple factoring from the last video. So we have x squared plus 7x plus 10. Now from the last video, what we would have done is we would have factored the 10. We would have went factors of 10 are 1 and 10, 2 and 5, and we want two numbers that add to the middle term, so 2 and 5, and then we'd rewrite the middle, or not rewrite the middle. Those would be our factors. Okay, so I'm going to show you the AC method. Now this method is quicker just for this one, but not overall. But I wanted one that you knew how to do so you could see it. So here we go. X squared plus 7x plus 10. So our first step, right, is multiply a times c, the leading coefficient times the constant. So here's the leading coefficient. It's a 1. So 1 times 10 is 10. Now, what we get when we have AC, or a times c, our next step is we're going to take the factors of this product from step 1. And we're going to find factors that add or subtract, depending on the sign, add or subtract to give us the middle term. Okay, this is the B term. So let's see, 1 and 10. Well, 1 plus 10 is 11, so not 7. 10 minus 1 is 9. 1 minus 10 is negative 9. Negative 1 minus 10 is negative 11. So none of those numbers work to give us 7. So we'll move on. We have 2 and 5. Well, 2 plus 5 is 7, so those numbers will work. Okay. So these are our two factors that we found that add to our middle term, or our 7. Okay, now the next step. We're going to rewrite this original equation, but we're going to rewrite the middle term as a sum of these two terms. Remember, sum means add. So we're going to rewrite x squared, and now the middle term is going to be both of these. So plus 2x plus 5x plus 10. Now notice, if I were to combine these like terms here, 2 and 5, I still get 7. So nothing's changed. I've just separated it. And now I can do something called factor by grouping. So that's the next step, is we're going to group the first two terms and the last two terms. Now make sure when you group that this sign, right, the sign goes with the number, goes with the term. So this is a plus 5, so the plus stays with. Now I didn't just all of a sudden start multiplying, I just made a group. So I'm going to put a plus here to remind myself I'm not multiplying. And you might feel like it's kind of redundant that there's a plus here and a plus here. You're going to see why when there's a negative here that it's not redundant. Okay. Now, the next step, we're going to take the GCF, the greatest common factor, which we learned about in the last video, take the GCF of the first term, and then the GCF of the second term. We do them individually, not at the same time, individually. So here, the greatest common factor, well, the only thing common is they each have an x. So we can factor out an x. If I have an x squared here and I factor 1 out, I had 2, I factor 1 out, I'm left with 1. And here I factored an x out, so I'm just left with a 2. Plus. Now here, our GCF, they don't both have x's, so we can't take an x out, right? This is a 10, not 10x. So x can't be factored out. But they each have a common factor of 5. We can factor a 5 out. So if I factor a 5 out of 5x, I'm left with just x. I factor a 5 out of 10. 10 divided by 5 is 2. Okay, now this step right here, like it says in your notes, okay, the moment you get to this point, you do that first GCF, which is what, step 4, I believe? Step 5. Once you get to this step right here, if what's in the parentheses are the same, see how these are identical? That means we're doing something right. If they're not identical, then you did something wrong. Okay? So you'll have to go back and recheck. Now we take the greatest common factor of the entire thing. Well, the only thing that's the same about everything is x plus 2 and x plus 2. See, these are identical, so they're the same. So we can factor out x plus 2. And if I take x plus 2 out here, I'm left with just x. And if I take out x plus 2 here, I'm left with just a positive 5. And I'm done. Okay. Now, like I said, this one might have been a little bit quicker to do it the other method, but I wanted to introduce you to the AC method using one that you could do on your own to kind of start getting the steps. Now let's do the next example. Okay, so a more rigorous example. So we have 2x squared plus 11x minus 21. First step, leading coefficient times the constant, a times c. A times c. So 2 times negative 21 is negative 42. You need to carry that sign through. Okay, so we got negative 42 as a times c. Second step, we want to figure out factors. So 2 factors of negative 42 that add to positive 11. Let's see. 1 and 42. There's no way to get to 11 from there. I feel like that's kind of easy to see. 2 and 21. Not really any way to get to 11 there either. Let's see, we got 3 and 14. Oh, well, hold up here. I need a negative 42, so if this is a minus 3, that negative 3 times 14 is negative 42, and negative 3 plus 14 is positive 11. Perfect, that's exactly what we want. So negative 3 and 14. So now, step 3, I'm going to rewrite the middle term as a sum of these two. So 2x squared minus 3x plus 14x minus 21. Okay, you'll notice that these are like terms. If we were to combine them, we'd still get 11, but we separate them to get our factor by grouping here. Group step 4. We group the first two terms and the last two terms together. Step 5, greatest common factor of each group individually. So the greatest common factor here, what do these have in common? Well, they only have an x in common. So I'm going to factor out an x. If I take 1x or factor 1x out from 2x squared, I had 2. I factor 1 out, I have 1 left. And I factor an x out of the 3x, so minus 3. Now here, once again, there's no x, there's not a common x because negative 21 doesn't have an x. But 14 and 21 are divisible by 7, so that's a common factor. So plus 7, 14 divided by 7 is 2. Negative 21 divided by 7 is minus 3. Okay, this is step 5. So these are identical. What's in the parentheses are identical. That means I'm doing something right. Now, step 6, greatest common factor of the entire polynomial or the entire expression here, which is 2x minus 3, right? These are identical. So I'm going to factor out a 2x minus 3. Here I'm left with just an x. And here I'm left with just a 7. And there's your answer. Now, this would have been more complicated if we did the guess and check method because it would be 2 and 1. Okay, and then you would have to check factors of 21. So you'd have to guess and check, whereas here, there was no guess and checking. Okay, no guess and check. It was just follow the procedure, follow the method. All right, on to page 3. I have some practice here. We have 3 of them that we can practice. So I'll do those with you. Let's see, 4x squared plus 4x minus 35. So A times C, 4 times negative 35 is negative 140. We want factors of 140 that add to 4. So let's see, 1 and 140, obviously not. 2 and 70, nope. 3 doesn't go into 140, but 4 does. That's going to be 35. No, still nothing. 5 and let's see, 28. That give us 4. Nope. 6 doesn't go into 140, but 7 does. 7 and 20. Let's see, how about 8? No, 8 doesn't go into 140. 9 doesn't. We have 10 though. 10 and 14. Oh, hey, I can get 4 from 10 and 14. If this is a minus 10, then minus 10 times 14 is negative 140, and minus 10 plus 14 is 4. So these are our two factors. I'm going to rewrite 4x squared minus 10x plus 14x minus 35. Group the first two and last two terms. Greatest common factor here. Now 4 and 10 are both divisible by 2, and they both have an x, so I can factor out a 2x. I'm left with 2x minus 5. Here, 14 and 35 are divisible by 7. 2x minus 5. We're doing something right because these are the same. Now, greatest common factor of the whole thing, 2x plus 7. Oh, sorry, I got ahead of myself. Factor out 2x minus 5 times 2x plus 7. And there's your answer. Okay. Let's do the next one. Um, 16x squared minus 1. Now notice here that there isn't a middle term. There's not just an x. Okay? So if you want, write a placeholder. 16x squared plus 0x, right? There's no x's, minus 1. Okay, now we're going to do a times c. So 16 times negative 1, which is negative 16. We want factors of negative 16 that add to 0. 1 and 16, nope. 2 and 8, nope. 3 doesn't go into 16, but we have 4 and 4. Well, if one of the 4s is negative, negative 4 times 4 is negative 16. Negative 4 plus 4 is 0, so we're going to rewrite the middle term as 16x squared minus 4x plus 4x minus 1. Group the first two and last two terms. Greatest common factor here, well, 16 and 4 are divisible by 4, and they both have an x in them. So we're left with this, right? If I factor out 4x, then I'm left with just negative 1. 4x divided by 4x is 1. Here, there is no like terms. But we can factor out, or we can divide everything by 1, because it doesn't change anything. So I'm going to divide it by 1. Now these are the same, so we're doing something right. So we're going to factor that out. And there's your answer. Okay. Last one before we go on to the next part. Ooh, this is a big one. Maybe I should go get my calculator for this. I won't get a calculator. So you can see me make mistakes, and you can see me do some math by hand here. All right, so A times C, so 49 times 4, that's a 6, 3, 16, 196. Factors of 196 that add to 28. Well, 1 and 196 obviously isn't. 2 and, let's see, 98. Nope. 3 doesn't go into 196, but 4 does. Right, 4 and 49. We just did that. 5 doesn't. 6 doesn't. 7 doesn't. Or, hold up, 7. Oh, 7 does. 7 and 28. 9 doesn't. 10 doesn't. 11, let's see. 196 divided by 11. That's 1 with 7. No, 11 doesn't. I'm pretty sure 12 does. So that's 1 with 7 left over. I'm going to run and get a calculator real quick. Sorry. I know what you're thinking. Mr. McLean, you said you're not going to get a calculator. You're such a hypocrite. I am a hypocrite. But looking at the time, I don't want the video to be too long. So, yeah. So 196. 12 doesn't go into 196. Neither does 13. I think 14 does, though, right? Yeah, 14. So 14 and 14. Now this, 14 and 14, give us 28. Right? 14 times 14 is 196. 14 and 14 is 28. I just realized, duh, this is a perfect square of 14. I used to have my perfect squares memorized up to 20, but I don't anymore. Because I don't use it very often. Anyways. So I'm going to rewrite the middle term. Plus 14x, plus 14x, plus 4. Group the first two and last two terms. Greatest common factor, 7x. So what we left over is 7x plus 2. Here, greatest common factor is 2. So 7x plus 2. Greatest common factor of the whole thing is 7x plus 2, and what's left over is 7x plus 2. And if you so wish, you could write it as 7x plus 2, and because we're multiplying by itself, it is squared. This is called a perfect square. But this is your answer. Either one of them. Either one I accept. Okay. All right, the last little bit are these special cases. Now, technically, there's two special cases. There's perfect squares and difference of squares. We're only going to go over difference of squares for this year just because of time. A difference of square looks like this. Sometimes people like to write it like this. I don't, because that gets confusing with the with our generic, right? Our generic quadrilateral, or quadrilateral. What the heck am I talking about? Our generic quadratic. So I don't like writing it like this. That's how you'll usually see it. I like writing it like this. Essentially, what it is, you know you have a difference of squares. This is supposed to be a minus. You have a difference of squares is if the constant is a perfect square, the leading coefficient is a perfect square, and there's a difference difference sign in the middle. Okay. The way of factoring it super quick, I'll show you the example. So we have 4x squared minus 9. The super easy way of factoring this, or difference of squares, take the square root of the first term. So the square root of 4x squared is 2x, right? Square root of 4 is 2. Square root of x squared is x. And then take the square root of the last term. So square root of 9. Don't worry about the negative for this one, just the 9. Is 3. The square root of the first term is the first term. So 2x, 2x. The square root of the last term is the last term. 3 and 3. And then because it's a difference of squares, we put different signs in the middle. Plus, minus. Done. Okay. Now that, like I said, that pattern right there only works if you have a difference of squares like this. If you notice on the practice we just got done doing, this one right here, the 16x squared minus 1, that was a difference of squares. But I didn't show it to you because I wanted you to see that the AC method always works. So some more practice. These ones will be kind of quick. So let's see here. 9x squared minus 16. Square root of the first is 3x. Square root of the last is 4. The first term is the first term. Last term is the last term. Different signs. Okay. Let's do the next one. X squared minus 25. The square root of x squared is x. Remember, a square root and a square, they undo each other. Square root of 25 is 5. First term is the first term. Last term is the last term. Different signs. Okay, and there's your answer for that one. Now this last one, I just made this one a little bit more difficult so you can see that it actually always works for everything, even if it's not a perfect square, but I'll show you. There's not gonna be anything super weird it's not weird, but there's not gonna be anything like this on your test. As far as I know, because I'm not writing this part of the test, another teacher is, so they shouldn't be putting anything on it. Anyways, the square root of 144 x squared is 12x. The square root of 5 is just the square root of 5. Okay, you might put it in your calculator, type in square root of 5, and you'll get a decimal. It's going to be 2.4 something, I think. That's not right. Remember, that square root of 5, it's an infinite decimal. So it doesn't matter how long you write for, it's never going to be correct. So we're just going to leave it as square root of 5. So when we put it in, first term is the first term. Last term is the last term. And then different signs. And there's your answer. Okay. So once again, I put this one in there to kind of challenge us a little bit to step outside our comfort zone and practice more difficult things. Basically, if you can do stuff like this, the test is going to be super easy for you. All right, and that's why I put it in there. And then we have that last question, it's the application. So we have a rectangle, it says. And it says the length of one side of the rectangle is 3x plus 5. And the total area is 12x squared plus 11x minus 15. We want to find the width of the square. Okay, well remember, area is length times width. So we have 3x plus 5 times another binomial. We're trying to find that binomial. But we do know the area. We know what the product is. So if we go backwards, if we work backwards, we can find, right, we can rewrite it as the product, and we can find that factor. So we're going to factor that polynomial, or that quadratic. It is a polynomial. So we have a times c. So 12 times negative 15 is negative 120 and 60, negative 180. Factors of 180 to add to 11. 1 and 180, no. 2 and 90, no. 3 and 60, no. 4 and 45, no. 6 and 30, no. I'm going to write over here. 7, it's not divisible by 7. 8, let's see, that's 16 to, not divisible, 8. 9 and 20. Oh, hey, 9 and 20. So if this is minus 9 and positive 20, then that adds to 11. So we have 12x squared, rewrite the middle term, minus 9x, plus 20x, minus 15. Group the first two and last two terms. Greatest common factor here is 3x. We're left with 4x minus 3. Greatest common factor here is 5. We're left with 4x minus 3. Greatest common factor of the whole thing is 4x minus 3. what's left over is 3x plus 5. Okay, so here's our product. Well, we're given 3x minus 5, so the other side, the width, must be 4x minus 3. And there's your answer. Okay. That is it for the video. Once again, right, if you need extra help or things like that, come in after class. Let's do a Zoom meeting. But please, please, please let me know. If you have questions, please ask them. Don't let yourself get behind on things. All right, and I'm always here for you.